So now that we're familiar with our Schmitt trigger circuits, let's revisit our streetlight problem and see if we can't improve upon the design. So here you can see I've copied our circuit from a previous video, and what we're going to want to do is we're going to want to focus on upgrading this simple comparator part to a Schmitt trigger so that we can sort of mitigate the effects of this noise that we added in our V sub n. So what we're going to want to do is, instead of just having the comparator, we know we're going to want to have positive feedback, so we can go ahead and put a feedback resistor coming from our non-inverting terminal to our output. And so all of our equations are easy to recognize. We can go ahead and call that R2. So now in this particular case, we have our input voltage VI coming onto our inverting terminal. So we know we're of course going to have an inverting Schmitt trigger, and we also know that we want to have this Vref, but let's go ahead and add our resistor R1 in here as well. So we'll get something that looks like this. Okay, so that's all the change we need to make to our circuit. We just needed to add those two resistors R1 and R2. So now let's look at what our output looks like with this as opposed to our comparator. So here I've just copied the exact same plots I had from a previous video. One thing to mention is that we are no longer using Vref, because now we are talking about our switching voltage, Vs. And so that's an important thing to note. So remember, if you go back to our previous video, we had equations for our switching voltage, and our switching voltage does depend on Vref, but it is not equal to Vref. So it's Vref times some combination of these resistors R1 and R2. So our Vs is our switching voltage, so that's sort of like the middle, assuming we have symmetrical VH and VL, that's sort of the middle of our threshold region, or the middle of our hysteresis loop. And then on either side of that, we're going to have a upper threshold and a lower threshold. So VTH and VTL. So let me go ahead and draw sort of some lines across here, indicating those two levels on this plot. And now, so remember what our comparator, our Schmitt trigger, is doing in this case. It's saying if we are increasing, we're going to have to go across our VTH before we change our value. If we're decreasing, we have to go across our VTL before we change our value. So if we kind of follow along this path here, so let's maybe make this a little smaller so we can follow easier. So we're going along this path, maybe a little bigger than that. So let's try this size. So we're going along this path here. We've not crossed any thresholds, so we're not doing anything. Our input is still small. We're inverting, so because our input is small, our output is going to be high. So let's just come down here and write that we're starting with a high output. Okay, so we are still going, we cross our lower threshold, but that doesn't really matter because we're increasing. Well, not because we're increasing, but because our output is high. So we continue increasing. We cross our V switching, but remember that doesn't do anything. That's just the middle of our hysteresis. So nothing actually happens until we cross our upper threshold. So because our input voltage is increasing, we're looking for that upper threshold, and once we reach that upper threshold, that is where our output is going to change from low to high, or in this case high to low, because we have an inverting configuration. So once we get to that point where we've crossed our upper threshold, we're going to switch to V low. And so as you see labeled here, once we're at V low, that corresponds to turning our lights off. So our lights had been on until that time, so it's gotten bright enough so now the lights can turn off. And so let's go back to following along this path. So notice our VI is still increasing. Now it's decreasing. So now we're decreasing. So when we're decreasing, we actually need to hit that VL in order to change our VTL. But we are not hitting that VTL. We go below VS, but we still haven't hit VTL, so we don't change states. And now we're increasing, we're above VTH, but we don't need to transition because we're already in that state. And of course, above here, we're not passing any of those transition lines. So what we can see, the ultimate effect here of using this Schmitt trigger, is that we were able to eliminate a lot of that chatter effect that we saw earlier. So we've eliminated our chatter effect. And so the reason we were able to do that is because instead of having one threshold, whether you're going up or down, we have a separate threshold for if you're going up than if you're going down. And so by going up or down, I of course mean our input increasing or decreasing. And so what that translates to in our physical system is instead of our lights flickering on and off around dawn and dusk, or maybe when there is a lot of cloud coverage, now our lights are just clicking on and off a lot less frequently. So that's all for our Schmitt trigger circuits. Like I said, we're going to come back in some later topics and we're going to talk about some related ideas. But for now, that's all. Please do let me know if you have any questions about this. And one other thing I'll say, a useful example if you want to get some more practice, there is a design example, 15.7 on page 1093 in your Neiman textbook. So I would encourage you to take a look at that. And as always, let me know if you have any questions.